We are on 1.3 notes. We're going to talk about midpoints and bisectors. So the midpoint on one dimensions just means a number line. The midpoint is the middle, midpoint, the point in the middle or the center of a line segment. It is the point halfway between the endpoints. So the midpoint formula would be to add the two endpoints. So, sorry, having trouble with my camera. You're going to add the two endpoints and divide by 2. So let's put, I guess, x1 plus x2 divided by 2. So here, if you go 2 plus 28 and divide by 2, you get 15. So that would mean right here, I didn't draw it exactly right, but the midpoint would be 15 because it is 13 units away from 2 and it's 13 units away from 28. So let's practice that. Let's say in this picture, let's find the midpoint of each segment. So the midpoint of AB. A is at -4, B is at -2. Add them and divide by 2. And you can see that it's -3, but we will see that the formula verifies it. The midpoint of AC. A is at -4, C is at 1. That is -3/2, which I can also write as -1.5. So that would be right here. You can see that it's 1 2.5 away from A and 1 2.5 from C, so that is correct. Midpoint of BE, you've got -2 plus 4 over 2. That's 2 over 2, that's 1. So easy enough, and if you've got the number line there and the numbers aren't too big, you can actually just count. But then let's look at the midpoint on a coordinate plane. So if you have 2 points here, I'm going to keep moving this. If you have 2 points here on the coordinate plane, to find the point in the middle, that's an XY, not just one number. You would add the 2 x's and divide by 2 to get the new x value. Add the 2 y's and divide by 2 to get the new y value. All you're doing is averaging the x's, averaging the y's. So if we'll look at the first example, find the midpoint of AB. So you could call this, I don't care which one you call, x1, y1, x2, y2, doesn't matter. But you add the 2 x's, -7 plus 3 over 2. That's -4 over 2, which is -2. Then you add the 2 y's. So for the y, we've got 4 plus -4 over 2, but that's just 0. So here's your midpoint. The point -2, 0 is halfway between these. So we could have graphed it. Hold on while I look for something. All right, we could have graphed it and counted, but what I want to show you is if I had graphed it, we have the point -7, 4, 1, 2, 3, 4, 5, 6, 7, 4, and then we have the point 3, -4. Do you see how since it's on a diagonal, it's a little hard to tell where the midpoint is? But if I use the formula and get -2, 0, that looks about right, doesn't it? So this formula works. So let's do it on this one. We're going to add the 2 x's, and we're going to get 0 again. That's weird. Add the 2 x's and divide by 2. And then we're going to add the 2 y's and divide by 2. So I'm going to get 0, -1. So see how it is a coordinate point, it's not just one number. All right, congruent segments. If the measures of the segments, the lengths of them are the same, remember we wrote the length of AB as AB with no line over it? Only lengths can be equal. So if the length of AB is equal to CD, then we can say that the segment AB is congruent. It's an equal sign with a little squiggle over it to segment CD. The measures, the numbers can be equal. The segments, the geometric terms here can be congruent. So now we're going to talk about the midpoint of a segment. Okay, so the midpoint of a segment is a point that divides the segment into two equal segments. So this would be equal lengths. So it is a line, ray, or segment. So, not it is. If a line, ray, or segment like this intersects a segment at its midpoint, it is said to bisect the segment. Bi means two, sect means cut it. Cut it into two sections, two pieces. And it is called, this is a tough one, the segment bisector. It bisects the segment. It cuts it in two, so it's a segment bisector. So in the diagram to the left, B is the midpoint of AC, segment AC, and line L, that's an L right there, is a segment bisector of segment AC. Now, the way we know this is these two marks right here. Do you see this mark and this mark? Those are congruent marks. If two things have one mark, they're congruent to each other. So I don't assume, I don't ever look at this and go, oh, B looks like it's in the middle. That's a midpoint. No, but I know it's a midpoint because of these congruent marks. If they cut it into congruent pieces, then the point it went through is the midpoint. The line itself is a segment bisector. So let's look at this one. Now, we are not going to assume anything. We're not going to go by what it looks like. It tells us Q is the midpoint. So find the value of X. So if it's the midpoint, what do I know? I know that these two segments are congruent. Therefore, I know that their lengths are equal. So all I do is set the two segments equal to each other, solve for X. Take away your 4X and make 3X. Bring down, okay, add your 16. You get 3X equals 18 and X equals 6. Now, you could plug it in to check. If you plugged it in, if 6 is right, it should give you the same amount for these. So it's going to give you 26 for this one and 26 for this one. So yes, it's correct. Now, if H is the midpoint of GI, so it's telling us H is the midpoint, which means these are congruent. So I can say 5X plus 2 equals 9X minus 10. So I can take away the 9 and take away the 2. I can divide by -4. Now, did it ask for X? No, it asked me to find GH. So now there's no segment length over it. That means no segment mark. That means I'm finding the length. So I take, does it matter? If they're congruent, I could plug it into either one of them. But if I take GH, I've got 5X plus 2. And instead of X, I'm going to put this 3. That's 15 plus 2. That means the length of GH is 17.